So let's start with the session. This is what we're going to discuss based on the chemistry part. We're going to look at matter, right? If I were to ask you what is matter, you have learned this in grade 8 or even grade 9, somewhere there, right? By now, as science students, we should be able to define a word matter. When you walk around, you see many things. There is air, there are stones, there are tables wherever you are, there are chairs. Kurenje, there is everything that you can be able to see with your own naked eyes, right? And those things we said as a chemistry students or science students, we know that everything that we see, it is made up of matter. So matter basically in a nutshell, it's when we talk about the element. So from the periodic table of which I know we are familiar with it, we know that periodic table is made up of the elements. So those elements, they found everywhere we go in this world. Okay, so when we talk about matter, we say that matter is described as anything that has mass and occupies space. Like I said, anything that has mass, even a feather, a simple feather from a bird, it is light in weight, right? But you have to know that it has its own mass. Even the smallest particles that you can think of, they have their own mass. Even an atom itself, it has its own mass. Even the electrons inside of the atom, even the protons, even the neutrons inside of the atom, they have their own mass. So anything that has mass and occupies space, we discuss that or we describe that as a matter. Okay? Okay? So you have to understand that chemistry, it is the science. Chemistry, it is the center of science, right? Because it studies everything in this world. Even look, even when you go outside, there is air, air. You can't see air, yes, but you know there is air. That air, it is matter because it is made up of particles such as oxygen, nitrogen. There are gases lingering all over into the atmosphere. Korenje, there are particles everywhere we go. Okay, so that's matter. Now we say there are three states of matter, of which I know we all know it, which is liquid. I hope you are saying it with me. We have liquid, we have solid, and we have gas. But if I have to be honest with you, there are four types of matter, or three states of matter. It's just that when right now, you're just gonna learn only three. Okay? Even at higher levels, they will always say there are only three. The fourth one, it is called plasma. Okay, plasma is like jelly-like structure. I know you guys did biology in grade 9, even here in grade 10, 12, even in 11, there is biology. Ne? We have learned the structure of a cell. So cytoplasm, that state of matter, it is plasma. Even inside of the nucleus, we have nucleoplasm. So inside of the nucleus, that state, it is called plasma. But that's another state of matter. But this we only focus on three states of matter, which is liquid, solid, and gas. Right? Right. And then now we say all that you see around you is made up of some kind of materials or other. That's what I told you right at the beginning, that anything that you see, I don't know, where are you sitting right now? Maybe on the table. What do you see? Maybe it's cold here in Free State. I don't know. It's cold. You're sitting next to a cup of coffee there. So that cup of coffee, the simple cup, it is something that you see that is around you. So that means that cup of coffee, we consider that as what? As material, right? So, like I said, materials, guys, you should be able to distinguish material and matter. Material, a cup of coffee is a material. But what made that material? That material, it is made up of atoms. That material, it is made up of elements. The very same elements that you see on the periodic table, that cup of coffee is made up of elements. And those elements, we consider them as matter. Do you get my point? So there is a difference between a material and matter, and you should be able to know the differences between the material and the matter. So material, it is that thing that you, even a wallet, even the glasses, even the phone is a material, or phone is made up of different materials because we have a battery, we have the glass, which is for screen, we have the cover, which is the plastic. So those are different materials in one object. So those materials are made up of matter as well. A glass, it is made up of its matter. A plastic that covers the phone, it is made up of its matter. The battery that is at the back of the phone, it is a material, but it is made up of its matter. Do you get the point? So you should be able to understand what is material and what is matter. So these are three states of matter. So tomorrow when they come and ask you define matter, you should be able to do so. This is a definition of matter. If they come to you and they say state, give three states of matter, solid, liquid, and gas. And what is material? Material are thus made of matter. Okay, simple as that. I hope that was understandable. Now let's talk about matter and materials together, of which is what we have already spoke about, right? I said all objects. I spoke about the objects, right? I said to you, we have the objects. But here's the thing. Objects can be classified into two objects, right? We live in this world. We make new objects. We find new object in this world. So there are two categories of materials, or there are two categories of objects. Some objects are man-made, which is made by you and me. Some objects are natural. We found them here on the planet Earth. So these are materials, right? Let's have a look at what? A cup of coffee, the very same one that I was talking about. A cup of coffee, it is a material. But what type of material is that? It is a man-made material. I can say to you, give me examples of man-made materials. You don't have to think hard. You don't have to think hard because you live in this world. Please, all of you, open up your mics and give me, let's start with, let me see who do we have here. Let's start with Rauhelo. Give me one type of material. I mean, man-made material.
Um, I could say a stop sign, sir.
Oh, come again?
A stop sign.
What? I'm sorry?
Uh, a stop sign.
Or a stop
It's a
sign.
man-made
Yes.
material.
A stop sign is
Yeah.
an object, and you are 100% correct. A stop sign. That's correct. Thank you very much. That then, like, give me one man-made material.
A stove.
A stove, say, a stove, say, a stove. It is made up of, yeah, materials, right? It's a man-made material. That's absolutely correct. Tato, give me one material, a man-made material.
A table, sir.
A specific table, right? That's absolutely correct. So that's, you see, you don't have to think at all. You don't have to learn that from the books. You can think about those things, right? So some questions, you need to be more general on them than wanting to learn from the books specifically. Now, another types of materials, we say they are natural. So what are natural materials that you can think of? Tato, give me one example.
Of a natural material, sir.
Yes. You don't have to think hard.
Sir, can I say wood?
Wood, absolutely. You said a table, it is man-made. And then you said wood, it's natural. You are correct. Because a table, it is a table because it was made out of wood. If you pay attention, so some of the things, for them to be man-made, we make use of natural materials. Do you understand? We make use of natural materials to make another material. So table is you didn't come into this world and then you just found the table there. No. Yes, three, you found it here. It's a biological organic. It's a biological material organism, right? It's a living organism, three, which is biological. Like, which is biological. So you found the tree here on this earth. It's naturally made, and it's a material which is wood. That's absolutely right. Okay. So yeah, I'm not gonna. That's it. So the man-made, we sometimes refer to them as artificial, right? Materials. Now we also look at the properties of materials, but you have to understand that the properties of materials depends on composition of material, and we use these materials depending on its properties. What do I mean when I say that? Let's think about um, wood and a steel. Wood and a steel, they are both materials, right? And we want to make, okay, let's say wood, steel, and plastic. Let's say we have wood, material one, material two, it is a steel, material three, it is a plastic. Now, this is what we want to do. You run a business, and in this business, maybe you sell watermelons. And when you sell watermelons, you cut your watermelons on top of your table. So the question is, which material it is appropriate for you to run your watermelon business when you cut? Or which material would you prefer to make a table? Would you prefer to make a table of wood? Would you prefer to make a table of a steel? Would you prefer to make a table of a plastic? All of these materials, they have their own properties. Let's just specify that specific property for each and every material that would suit the use of this material. What do we want to use this material for? We want to make a table. Is it fair if I make a table out of a wood? Is it fair if I make a table out of a steel? It is fair if I make a table out of a plastic. I want to chop my watermelon. The reason why I'm picking watermelon is because watermelon, it has water in it, right? So here's the watermelon. I chop on my table and there is water all over the table, and the table, it is made up of this material, which is wood. We know that the properties of wood and steel are not the same. The properties of wood is that wood is not a metal. That's the first thing. A wood, it is a non-metal, right? And we know that if there is water on a metal surface, water will be absorbed through the metal surface and not metal surface, a wood surface. Water will be absorbed through a wood surface, and with time, or as time goes by, what's going to happen with that table? The table will start to decay. It will rot. Again, it will rot because water, we know that the reactions that are taking place, there is a complexity behind that, which is chemistry part. So the wood will eventually fall off, or it will no longer be sustainable because of their properties, the way wood it is structured, the atoms inside of the wood, all of those things. Now let's talk about steel. We take it. So this is not a good choice to form a table, right? If you run a certain, for I get it, the use here, we want to make wood, we want to make a table so that we can run our business. Like, so that business, we sell watermelons and we chop on top of the table. So this is not an ideal option. You're a scientist, and then you come to a steel. Would it be possible for me to design a table, a steel table? Have your watermelon, you chop your watermelon on top of the table. Here's the thing about the steel. A steel will corrode. Why? Because we know that when water touches the surface of the steel, what's going to happen is that oxidation reaction will take place. We call them the redox reactions. So oxidation reaction will take place over here. Therefore, the steel table will start to corrode. In our usual language, you guys understand this, Sesotho, it's gonna rust. You understand? Because the steel combined with water, the oxidation reaction will take place. That oxidation reaction will result into what we call a rust on the table. Not corrosion per se. Why I don't know why I keep on saying corrosion. But I think it's the same, but yeah, a rust. It will result into a rust. This is not an ideal to design a table for our business based on that property because it's a metal. Understand? Metal reacts with oxygen. That's a property. And therefore, let's talk about the plastic. Plastic doesn't absorb water, number one, like wood. Plastic doesn't corrode, doesn't cause a rust when you have a water on top of it. So the ideal option is to use a table that has a plastic, a table that is made up of a plastic material. So that's why here I wanted to bring this alive to you so that you can understand when we talk about the properties, what are we actually talking about? We say the properties depend on the compositions of material. So plastic, it has its composition. It has its own material, it has its own atoms, it has its own elements compared to steel, compared to wood. Like even wood, it has its own elements, it has its own atoms compared to steel. So those compositions of elements, they define the properties of these materials. You understand? So that's why here we say properties depend on composition of material, and uses of the material depend upon its properties. So like I said, what do you want to use this material for? To make a table. For what purposes? For watermelon business. That's a use, right? So yeah, based on the properties, you will be able to select what type of material to use. You cannot just use any material. You want to make a car. Can you make a car with a wood? It's a material. No. Can you make a car with a plastic? Yes, you can. Nowadays, cars are made of plastics, the body of the, but not everything, obviously. But the engine, that's where you're gonna need the steel and all of those things. So you understand. So that's what I'm saying to you. Chemistry, it is the center of science. Whether you're doing mechanical engineering, you still have to abide by these chemistry basics. You understand? So this is a pure science from the core. All right. I hope I explained that better, because this is just the definition. It's just a word that needs to be explained, and I explained it, and I hope it really does make sense to everyone. I'm waiting for this to respond. I'm going to erase all the incorrect. Now, let's talk about, since when we have properties, we can divide these properties into two. We have the physical properties, we also have the chemical properties. Remember, we are talking about the materials here. I want you to have a clearer picture while we are explaining this. So when we talk about the physical properties, what are we talking about? Number one, we look at the appearance of material. Look at the wood, look at the steel, look at the plastic. Their appearances are totally different. So that's a physical property. It's physical because it's something that you can see with your own naked eye. Something that is physical, you can see it. Right? You can understand it. It's not chemical, it's not like on the reaction level. And then another property is strength. We're going to look at the strength. Look at the strength of the wood. Look at the strength of the table. Look at the strength of the wood. Look at the strength of the steel. Look at the strength of the plastic. The strengths are not the same. And based on the strengths, that's where we can talk about ductility. We can talk about the malleability. We can talk about the conductivity. We can talk about the toughness. That's the strength. Which one it is more malleable between the wood, between the steel, between the plastic? Which one is malleable? Which one it is ductile? Which one it is tough? Which one is a good conductor? Whether good conductor of electricity or good conductor of heat. You should be able to know those things. Okay, so We are talking about the physical properties of materials. You look at those things. And then lastly, we're going to look at the electrical and heat conductivity. Is it the wood material a good conductor of electricity? You should be able to know that yes or no. Is it a steel a good, or a wire, or an iron? An iron, is it a good conductor of electricity? Or a plastic, is it a good conductor of electricity? And you come back again and ask yourself, is iron, wood, plastic a good conductor of heat? You should be able to know those things. We're gonna learn, we're gonna see, we're gonna look at the examples, okay, when it comes to such things. But here we were simply talking about the physical properties. So I was just explaining them for you to understand why do we consider them as physical properties. Remember, properties depend on the compositions. So we're going to look at appearance, strength, electrical, and heat conductivity. Okay. Then we have what we call the chemical properties. How substances react in chemical reactions. That's a chemical property. How does this react? What is that reaction? Remember, I said water can react with oxygen to form rust on a steel material. On a plastic material, there is no such of reaction. So the chemical properties of water are man, the chemical properties of a steel table and the chemical properties of a plastic table are definitely not the same. Because the steel one, the chemical reaction will take place based on the composition, because metal can react. That's the problem. Steel, it is made up of metal. So the problem is the metal can react, but the plastic cannot react like that with water in the presence of oxygen. Okay. So to not confuse you, I hope you understand the differences here. The first thing that we started with, you can note it down, definition of matter, right? After defining matter, we looked at what states of matter. And then after that, we discussed what is a material. Material, it is made up of matter, but now you know what is material. I even gave you 3 types of materials that you can refer to. For example, steel, wood, and plastic. And then we also spoke that material can be divided into 2. We can have 2 types of materials, even though we know that material, it is made up of matter, but we can have 2 types of materials: man-made, which is artificial, or natural, right? And we even gave few examples. And then we also looked at the properties of these materials. So the properties, it does not matter whether it is man-made or it is natural. So the properties of materials, it really does not matter. Sorry, which material are we referring to? Are we referring to artificial or are we referring to natural? But the properties, it doesn't depend on that. It depends on the composition of material. Then we saw that there are 2 types of properties. We have the physical one and we have the chemical one. And the physical ones, we have their examples as well. What are those properties? For chemical ones, we know now what we look at when you talk about the chemical properties. So far, do we all understand? I want to be slow as much as I can. Do we all understand?
Yes, sir.
Okay.
Yes, sir.
Um, now, let's run a little bit away from matter and materials. We spoke about matter and materials. So what is matter? It's the introduction, right? Because remember, this concept is called matter and materials. Hence why we had to get a grasp of what is matter and what is material. What does material look like? Yeah, and all of those things. Now, I want us to talk about the mixtures. Yes, mixtures. Vingevongo. Combination of different materials, combination of different substances, combination of different compounds, whatever you can call it. The very same food that you eat in that bowl, that's a mixture. seven colors. You have your potatoes, you have your pumpkin, that's a mixture, right? But we are in a chemistry level at this point in time, and we want to understand what are mixtures, okay? There are two types of mixtures, but we will look onto that. So in a simple sense, if they ask you to define, okay, what is a mixture, you should be able to know that it's a combination. Or the moment you start by saying mixtures are combinations of what? Of two or more substances that maintain, this is also very important, that maintain their physical properties and may be separated by physical means. So now here's the thing. A mixer, it is not what you might think it is, of which it kind of makes sense. What do I mean when I say that? A mixture should be separated. If you can't separate it, it is not a mixture. If you can separate it back, no matter you're going to use a complex method to separate those substances, or you're going to use an easy method to separate those substances, it does not matter. You should be able to separate that. So when you talk about the mixture, you should able to tell that a mixture are combinations of two or more substances that maintain their physical properties, meaning they maintain their appearance. We saw what are the physical properties. They should maintain their appearance. You understand? Um, and may be separated by physical means. There are physical methods that we're going to make use of. So here's the example of a mixture. If you take a screws and nails in a bowl, can you separate that? Yes. How, which method are you going to use to separate the nails and screws in a bowl? You're going to make use of your hand. Take the nail this side, take the bowl, the screw this side, nail, screw, nail, screw, nail, screw, by using your hand. That's a physical method. Separation by hand, it's a physical method. Screw and nails, it's a mixture. What are the physical properties? The physical properties are that they still maintain their physical properties. Nothing changed about the screw. Yes, it's true. You combine the screws and the nails, but nothing changed about the screws. Nothing changed about the nails. Right? This is simple, basic understanding. Now, let's elevate to get more complex explanation behind the mixtures, okay? So apparently there are two types of mixtures, okay? There are two types of mixtures, and they're gonna ask you this. What are those two types of mixtures? Homogeneous mixture and heterogeneous mixture. Those are two types of mixtures. The first one, it is called homogeneous mixtures. The second one, we have heterogeneous mixtures. So that means screws and nails. What type of mixture is that? Does it fall under homogeneous mixtures or does it fall under heterogeneous mixture? You should be able to know that after we define these two types of mixtures. Ne? Now I know screw plus nails. What type of mixture is that? I can tell whether it is homogeneous or I can tell whether it is heterogeneous. But I will give you that task because now we don't know what is homogeneous, what is heterogeneous. Let's learn. Now, what is homogeneous mixtures? What is this homogeneous mixtures? Yes. Okay, let's go. Homogeneous mixture, we say this is how you define it all the times. This is the definition of homogeneous mixture. We say homogeneous mixture are mixtures that has uniform composition. Homo means the same. This portion, homo means the same. Have a uniform. Uniform means the same, by the way, or constant. Okay. So they have the same composition, or they have used the word uniform. They have uniform composition. We have water, I'm not good at drawing. We have water. We have a spoon of salt. We put this salt inside of water. We have water and salt. When I pour this salt inside of water, what's going to happen with it? I'm going to have a solution, right? Water plus salt, it gives us a solution. Water itself is a solvent. It solves, I get solvent solves solute. Salt, it is a solute. Solute, when it gets into the solvent, solvent will solve that guy, which is solute, and they have solution, right? That's solution. Solution is a combination of different. Or when I hear in chemistry, most of the time, when they say solution, you have to understand they are not talking about when they say a solution of sulfuric acid, a solution of sodium hydroxide is its concentration is this and this and that. Oh, solution. That means it is not a pure sodium hydroxide. It's sodium hydroxide added inside of water. We dilute that. So solution, each and every time when you hear a word solution, think of mixture. It's a solution. It can't be solution without being mixed. Water, it is not a solution, but water with salt, it is a solution. Water alone, it is a solvent. You get the difference. So when I put my soluble inside of the solvent, the solute, it is soluble because it can dissolve in a solvent. We say it is soluble. But something that cannot dissolve, we say it is insoluble. Solute, sharp and stuff. So here's the thing. Let me ask you this, ne? I have 2 glasses of water on the table. The other one has salt, the other one doesn't have a salt. Are you going to be able to tell? Okay, that glass there, it has salt. You won't be able to tell that. You won't be able to see which glass has a salt. Why? Because of that uniform composition. Because of that same. You see, water and salt, you won't be able to see salt. You just think it's gonna be water. You're gonna be like, oh, this is water. There's no salt. How do you know it's a salt? Unless you taste. When you taste, you're gonna be like, ah, right? You're gonna spit it out of your mouth because it's salty. This water is salty. That's when you're gonna be like, oh, this is a mixture. But what type of a mixture? Homogeneous mixture. Okay? All right. So now let's see. So you can't visually distinguish components of mixture, which is true. You can't say this is in this mixture, in this solution, I can see salt. Hey, I can see. You can't. You can't see salt. And then again, often in the same phase, they look like they're in the same phase. Salt, it is solid, it is solid, right? Salt is solid, water is liquid. Combine them, they all look liquid. Salt is no longer solid, it looks like liquid because you can't see it even. Same applies to when you combine, you can combine Pepsi and Coke. Pepsi doesn't taste like Coke, but you won't be able to tell, okay, this is Pepsi and Coke. You would think it's Coke or you would think it's Pepsi. That's homogeneous mixture. Even though it's brown or black in color, that's homogeneous mixture. So homogeneous mixture is not the case that it's supposed to be white, like it's supposed to be translucent, just like water. I know water is translucent in color, ne? So we can't expect homogeneous to be only translucent, even different colors, but as long as you can distinguish, okay, what is what in that mixture. And they're in the same phase again. So example is salt and water, like how I said it. Another example is air. Would you be able to tell, look, there is oxygen there is nitrogen there? You won't. The only thing that you see is air. Even the steam, the smoke from the fumes of the industries, you won't be able to tell, okay, that's carbon monoxide, that is carbon dioxide, that is methane, you won't be able to tell because it's a homogeneous mixture. It's mixture, but you can't see. Another example is alcohol and water. So most of the time we are referring to what kind of alcohol? The laboratory alcohol. Don't think of that beer, vodka of street in. Don't think of those things. Here we are talking about the alcohol like ethanol, methanol, the alcohol, the laboratory alcohols. Yes, the of street, that wine that you buy, go checkers. It is also made of alcohol, but I'm not talking about that one. Talking about the alcohol in the lab and water. They are both look alike. They look alike in color. They are translucent, both of them. So when you mix them, you won't be able to tell whether this is alcohol or water. Let me see you in the next upcoming session.